Okay, so in this lesson, we're going to talk about the inverse function or inverse of a given function. And the first thing we want to talk about is what does it mean when we say an inverse of a function or inverse function? Well, by definition, geometrically, in terms of Cartesian coordinate, I have this Cartesian coordinate here, x, y. So the top is y, and this is xy coordinate. When we say the inverse of a function is when you have a function that is reflected over the line, and this is supposed to be a straight line, y equal to x. Whenever you have a function that reflects over the line, this diagonal line of y equal to x, we can create inverse of a given function. So let me give you an example. So we have this function y equal to x plus 1. And here is the graph of y equal to x plus 1, okay? And the y-intercept here is 0, 1. And this is the equation of, this is a graph of y equal to x plus 1. If you want to graph the inverse of this function, what we need to do, we need to use this definition because it's a reflection over the y equal to x. That means as long as we switch, we change the x for y and y for x, we can actually graph the inverse. That means what? That means that based on this coordinate, if I flip the 0, 1 to 1, 0, so this is the 1, 0 right here, and so is this one. What is this one? This one, this coordinate right there is minus 1 comma 0. So when I flip that one, that becomes 0 minus 1, which is right around here. Okay, so in my diagram, the grid is not to scale, so be aware of that. So 0, negative 1. And then when I draw a line, the new line will go through the 2 points, and this becomes the inverse of y equal to x plus 1. And the way we write the inverse, we're going to use the function notation. So instead of writing y equals to x plus 1, we're going to write as f of x equal to x plus 1. And the inverse is written in using this notation, f inverse. You can call it the exponent, but it is not exponent, but it's just a notation, equal to, and this is the graph of it, but in terms of the algebraic equation of it, we have to do some manipulation. And to do that, we have to come back here, switch x and y around, and rewrite the equation for y. So here we're going to do x equals to y plus 1, and then we're going to solve for y. Y is equal to x minus 1. So f inverse of x, which is right here, okay, this is what we have there, f inverse of x, that's how you read it, is x minus 1. So we're going to come back here and we're going to do that. So that's the equation, that's the graph. All right. So the idea is the point AB is on f of x, okay? That means it's on the graph of the function. Then BA must be on f inverse of x, the graph of the f inverse of x. And BA must be on f inverse of x. So that's a very good thing to remember. And regardless of what the function is, this is a linear function, it works like this, but it can work for any function, no matter how sophisticated the function is. All right.